Hi, second year it's students, it's math with AUB. Just get along. Exercise 4.4, question from 1 to 3, half exercise. Wonderful application of calculus. Let me say differential calculus. Question number 1 reads as it is some sort of history. Thomas Malthus in 1798 proved that increase in population of a country or a city at a certain time is proportional to the total population of the country or the city at that time. Mathematically, it's this one. At present, the population of A is, our question starts from here. Thomas Malthus proved that in demography, in statistics, that increase in the population is directly proportional. It increases exponentially. Exponentially means having power, having power. If you are a mathematician, you are familiar. It increases at a geometric pace rate. Geometric, where r is greater than 1. R is greater than 1. It increases by leaps and bounds. Leaps and bounds. It jumps. And he gave rate of change in the population is directly proportional to P. Rate of change of population with respect to time is directly proportional to the population present. Our question starts from here. If at present, on the beginning, at the outset, population of the city is 20 million, and after 4 years, it is expected to be 25 millions. What would be the population of that city after 12 years? As Thomas has given, our mathematicians have already worked on this. A rate of change of the population is directly proportional to the time. At our beginning concepts of physics, we are familiar according to Newton's second law. Force is directly proportional to acceleration. Whenever we get rid of this proportional symbol, we introduce a constant of proportionality. A constant of proportionality according to this equation. According to this equation, that is mass. In that case, we have to generate a constant, say suppose Kp. Here it increases means the value of A must be greater than 0 for increase. For increase. For decrease, opposite is the case. Decrease. For decrease, K must be less than 0. One can ask, as a curious mind, what happens if K is equal to 0? If K is equal to 0, there is no change. There is no change. There is no change. There is no. These are three possibilities. As it is increased, we are interested to find K, and it must be greater than 0. Let's solve this differential equation. If you inspect the situation now, it is a separable differential equation. Separable differential equation. Separable differential equation. It can be written as dp kp times dt. Shift p towards dp. Mathematically, dp over p is equal to k times dt. It is integrating both sides with respect to their independent variable. dp over b, that's k times dt. It is famous case of ln. ln p is equal to kt plus c. kt plus c. In order to get rid of ln, to facilitate our calculation, it gives us, taking e as a base both sides, e ln p, e is kt plus c. Let me shed some light on that. Inverse of ln x is e power x, and inverse of exponential is ln x. These are inverse of each other. They are inverse of each other. If you want to get rid of either, introduce the other one. If you want to get rid of ln x, introduce ex as a base. If you want to get rid of ex, take ln as a base. That is the case. Cool, cancel out. I have p is equal to e raised kt plus c. If you are good at mathematics, I have already told you while solving differential equations, separable differential equations and homogeneous, tiny property of exponent gives us e raised c. E is a constant raised to another constant. It is a constant, pure constant. Let me introduce instead of e raised c as c1. As c1. Now utilize the conditions, given conditions. What is the population on the outset at starting point? At the starting point means we have t is equal to 0, initial point. Then after some time, then it is after 4 years, our population increases 25 million, from 20 to 25 million. Okay, utilizing these conditions, we are interested to find the value of this constant and this constant, C and K. We are interested to find C and K. Let's see how. Initially, initially means at t is equal to 0, population is 20 million. It is given to us. Initially, initially means at t is equal to 0, our population is 20 million. Utilizing that condition to find out the values of constant kt times c1. If I plug in value of t is 0 and p is 20, 20 e raised k times 0 c1. 20, any quantity raised to 0 but non-zero quantity. Any non-zero quantity raised to 0 power is equal to 1. Any non-zero quantity, mark my words. So c1 is our 20. We have taken a big leap forward. We have generated, we have manipulated, we have found out the value of C1 constant, E raised kt, C1 is 20, or I can write 20 times E raised kt. Okay, then after 4 years, P is 25 million. P is 25 million. After 4 years, P is 25. Now utilize these conditions. Put T is equal to 4 and P is equal to 25 to get the value of K. E raised K times T into 20. Our population is 20 now. After 4 years, value of T is 4 is equal to 20. Sorry, times 20. Shift 20 here. It's 25. Our population is 25. 25 divided by 20 is equal to E raised 4K. Applying table, I have 5 over 4 is equal to E raised 4K. I have just shared with you to get rid of E, introduce ln. To get rid of E, introduce ln. To get rid of ln, introduce E. So in that case, I have to introduce ln. I have to introduce ln in that case. Ln 5 over 4 is equal to, pass me the calculator, E raised 4K. I have forgotten to manage the calculator. Ln E raised 4K. Mine ln 5 upon 4. Sorry. Ln 5 divided by 4. Let me write brackets. Ln 5 divided by 4 bracket 2. That's my 0.2231. It's enough. And here power will become coefficient 4 times k ln e, 0.2231 dividing by 4. I have 4 ln e 1, only k remains here. Ln e is equal to 1. Ln e is equal to 1. I have taken 4 here. I have divided as well. So mine k is 0.055785. It's one value of k. It's one value of k. Now we are in a position to take the final jump. We have both constants. And what is the requirement of the question? Just find out. P is equal. C1 means 20 times e raised k. Okay, let me write here. C1 e raised kt. We have already generated value of C1, that's 20. E raised value of k is 0.05578 times t. Now we are asked to find the population when find the population of the city after 12 years. Insert population after 12 years. Population after 12 years. Now we have something like 20 e raised 0.05578 times 12. Multiply by 12. What I have? P is equal 20 times E raised 0.66948. It's enough. Now let me check shift. E raised point double six 94. I am expecting that you are familiar how to use calculator. 20 times. I have the answer 1.953 and so on. Multiplying by 20, I have P is equal to 39.0613026. 39 is enough. Approximately 39 millions is our population after 20 years. Sorry, 12 years. 12 years. After 12 years, after 12 years, our population is little more than 39 millions. Little more than 39 millions. Little more than 39 millions. It's our answer in that case. It's our answer in that case. What we have done, let's retest the step. First, we have taken the rate of change in the population with respect to time is directly proportional to the population. We have got rid of this proportional symbol by introducing a constant Kp. Then we solve differential equation. It gives us e power kt times c. We utilize the initial conditions to determine c and k. We utilize the initial conditions to determine c and k. We have t is equal to 0. Initially population is 20. When t is equal to 0, we have managed the value of c 20. And then after 4 years, our population is 25. Instead of p, I have written 25. Instead of time 4, then I have managed the value of k. That's mine somewhere here 0.05578. With the tiny use of calculator, you are familiar from this at this level. If I have both, now we have managed the constant. Both c is 20, k is 0.05578 here, and we are asked to find the population after 12 years. Just plug in the value of t is 12. Our population after 12 years would be 39 millions. Moving towards next question. Everybody's favorite pizza. Pizza baking and preparing, just recording its temperature. What is this or not? Let's see and find out. Aisha was preparing a pizza in a baking oven. Aisha was preparing a pizza in a baking oven. She observed that the temperature of the cooked pizza was 150. Temperature of the cooked pizza was 150 degrees Celsius. Okay. 4 minutes later, 4 minutes later, she observed that from the temperature of 4 minutes after removing the pizza from the oven, the temperature of the pizza was 90 degrees Celsius. Okay. How long? Then we are asked to find time. Capital T for temperature, small t for time. How long? We are interested to find time when the temperature of the pizza would become 40 degrees Celsius if the room temperature is very vital one. Room temperature. Room temperature means T naught. 20 degrees Celsius. 20 degrees Celsius. Don't you worry. That is the base temperature for you. That is the base temperature. Room temperature is 20 degrees centigrade. Everything has been done in the room. Everything has been done in the room. When pizza was cooked, its temperature is 150. 4 minutes later, 90. When it would have been temperature 40 degrees centigrade, we are interested in that. Room temperature is 20. Let's apply famous Newton's law of cooling. It states that change in temperature is directly proportional to the difference of the temperatures of the body and the ground state, of the body and the ground state, of the body and the ground state, of the body and the ground state that we are dealing in the T naught, the temperature of the system, in that case temperature of the room. So it is 20. It is 20. Take care of this thing. To get rid of proportional symbol, introduce a constant it would be t minus t naught. Now it's a separable differential equation. Separable differential equation. Take dt towards the right hand side from division to multiplication, k times t minus t naught dt. Capital T stands for temperature, small t for time. Managing the variable separate, t minus t naught is equal to k times delta t. Integrating with respect to their independent variables, dt over t minus t naught is equal to k is a constant k times dt. Again, it is a famous situation of ln t minus t naught k times t plus c. Mostly people get rid of this ln by introducing t, or not getting rid of this ln dealing here. It's up to you. It's up to you. Whatever suits you, just do that. I am taking e because your book has some sort of this solution. Otherwise, you can do from here direct. Just put values and keep on finding the results. Let's see how. I am not taking e as a base. Initially, when the pizza cooked and taken out of the oven, its temperature is 150 and our ground temperature, room temperature is 20 initially. Initially means T is equal to 0. Initially means T is equal to 0. Okay, cool. ln the temperature of the pizza 150, room temperature is 20. It is given to us. K times T initially T is 0 plus C. ln 150 minus 20, it will become ln 130. Now find the log of, it will become 0 plus C. So value of C is ln 130. ln 130, that's 4.8675. Okay, cool. That's mine C. That's our C. We have managed the value of C. We have managed the value of C. Now we are interested in K. Now we are interested in K. First we find C, then we find K, and then we embark upon the journey, whatever we are asked to find or do finally. Okay, making some room for myself. Initially means T is equal to 0. Initially T is equal to 0. Mostly I have, oh, I have rubbed this. I think T minus T naught, that is K times T plus C. Value of C is mine 4.8675 ln T minus T naught KT plus 4.8675. Okay. initially the temperature of the pizza 150 at 150 our time is 0. I have managed T is equal to 0. I have just manipulated the value of C. It is 4 minutes later. Now we arrive at a situation 4 minutes later. After 4 minutes, the temperature is 90 degrees centigrade and our T is 4. Initially T is 0, temperature was 150. Initially temperature 150 times 0. Now after 4 minutes temperature is 90. It is flowing now. ln T means 90. Don't forget our ground state temperature is 20. Ground state temperature, room temperature, that's 20. That's 20. T naught. K times T after 4 minutes, 4 and C is 4.8675. 20 minus 30, ln 70. What is the value of ln 70? Let's see. ln 70 is 4.24. ln 70, 4K plus 4.8675. ln 70 is mine 4.2, 4.24849. It's enough. 4K plus 4.867. Manage 4.67. Solve for K. Solve for K. We have 4.24849 minus 4.8675 is equal to 4K. Minus 4.8675. Cool. It is my negative 0.619 is equal to 4. Solve for k, dividing by 4. Divide by 4. We have 0.619 divided by 4. Then k is equal to negative 0.15475. Okay, look at this. In case of the first prior question, it is increasing. Increasing means we have k greater than 0. It is decrease. Now temperature is, pizza is cooling down. Pizza is cooling down. Temperature is coming down. Decrease, decrease. That's why we have k negative. If it is a question of increase, k must be positive, 100% positive. If it is a decrease, k must be negative. Must be negative, as is the case. As is the case. Now we have value of k, value of c. Finally, we are about to jump to the conclusion. What we have to do? ln t minus t naught is equal to k times t. Let me value the value of t. Let me write k and t here. Value of k here. What the value of t? K ln t minus t naught. I am putting here. K means negative 0.1475 times t plus 4.8675. 8675. Let me check again. 0.1515475. That's good. Now we are done. Now we are asked to find how long would it take to temperature of the pizza become 40 degrees centigrade, 40 degrees Celsius, 40 degrees Celsius, 40 degrees Celsius. Now ln T is going to be 40 in final stage. Room temperature is same 20. We have each and everything negative 0.15475 T plus 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 value of C is 4.865. 4.865. Now there is the T times T. Now solve for T and we are done. 40 minus 20, it's ln 20. Find ln 20. That's 2.9957 negative 0.15475 times T plus 4.8675. Shift 4 point, solve for T just. 2.9957 minus 4.8675 is equal to negative 0.15475 times T. How much it is? Let's see. Minus 4.8675. It is equal to negative 1.87176. I have taken just 3 to 4 digits. Negative 0.1547. 1.475 T. Negative negative cancel. Shift this quantity here. 1.87176 divided by 0.15475 is equal to T. Dividing by 0.15475. It's equal to, our time is 12.295. We are dealing in minutes. It takes approximately 12 minutes. The pizza took 12 minutes to cool down to the temperature 40 degrees Celsius. 40 degrees Celsius. 40 degrees Celsius for 12 minutes. Approximate. Let me mention the symbol of approximation. 12 minutes approximated. Little more than 12 minutes. Little more than 12 minutes. Okay, retrace the steps, as these are the wonderful applications of differential equations. According to Newton's law of cooling, according to Newton's law of cooling, it states that change in the temperature with respect to time. Capital T stands for temperature, small t for time, is directly proportional to the difference of the temperatures. It's our ground state temperature. Don't forget this. room temperature, ground state temperature. We are dealing in a situation in a vicinity in an area. The temperature over the period of time remains same, remain fixed. It is our base temperature. It is our base temperature. Take care of this thing. The rest is easy. We got rid of this proportional symbol. At is k times t minus t naught, then solve. It is a separable differential equation. T minus t times k times dt. We have ln t minus t naught is equal to kt plus c. I have solved from this situation. R take e as a base. You have t minus t naught is equal to e raised kt plus c, that we have done in previous question. T minus t naught, it can be written as e raised kt times e raised c. Another constant, let me plug in value e raised kt times c1. Okay, ground state initially means t is equal to 0. I have plugged in value of t is equal to 0, and when the pizza come out of the baking oven, temperature 150, room temperature is 20. Initially k times initially t is 0, c1. So I have managed 150 minus 30. It is the value of e c1. C1 is mine, 30 in that case, 30 in that case. But I have utilized with log. It would have it was something 4.8675. It was 48675. Let me manage. ln 130. Yes, 4.8671. It was the case. It was the case. Okay. Then after 4 minutes, the temperature is 90. Put capital T 90 and small t 4 minutes. Don't forget to carry on the legacy of the room temperature, that's 20. Okay, then we are in a position, we have determined the value of k. Value of k, it would have been some sort of negative. After determining the value of c and k, jump to the conclusion what it is required. We are asked to find the time, how long would it take that temperature of the pizza would become 40 degrees Celsius initially. It would have taken 12 minutes in our case. It would have taken 12 minutes in our case. Okay, cool. Moving towards final question, that is the population increase? Same, almost same, almost same. Where lies the difference? In my opinion, the difference lies in value of k. If it is increased, k is positive. If it is increased, k is positive. If it is decreased, k is negative. K is negative. Okay. Sorry. In a culture, the rate of the growth of the bacteria proportional to the population present. Same change of the population with respect time is proportional to the population present. dp over dt we have already done. Take ahead, introduce a constant of proportion, that is k. In that case, if it is an increase, k must be greater than 0. K must be greater than 0 means k positive. Separate differential equations. Let me change marker as well. Manage ink, and I have dp over p is equal to k times dt. Integrate with respect, they are independent variables. dp over p, k times dt. Okay, it's ln p kt plus c. It's up to you. Deal here or get rid of this ln by introducing p. It's up to you. In the first question, I have got rid of ln. In second, I have not. In third, again, I am getting rid of this e. Taking e as a base, I am getting rid of this ln. E raised kt plus c. Cancelled out. I have p is equal to e raised kt times e raised c because a raised m plus n can be written as a times m times a raised n. I can write tiny exponent rule. It is another constant. Let me introduce instead of this as c1 another constant. P is equal to e raised k times c1 or c1 e raised kt. Now I manage the value of C1 and K by utilizing initial condition. By utilizing initial condition that is given to us. Okay, if the population of the bacteria becomes 4 times in 2 days, how much the population would be after 10 days at the same rate? If initially the population was, initially population is 20. We have no idea how much, 20 exactly, 20 million, whatever the case is. Population of the bacteria is 20. initially. Let me manage the value of k and c. I have p is equal to c1 e raised kt. Initially means t is equal to 0. Initially population is 20. It is given to us population is 20. Initially 20 c1 e raised k times 0. Initially t is 0. 20 is equal to c1 times e raised 0. It's 1. So value of c1 is 20. So value of c1 is 20. So value of c1 is 20. Plug in here. We have something like p is equal to c1 means 20 e raised kt. E raised kt. Now we have to manage the value of k. Where is the value of k? What is the other condition? In the culture of the bacterial gas is proportional to the if the population of the bacteria becomes four times in 2 days. Population will become four times in how many? In 2 days. If I am not wrong, in 2 days. Time 2 days. Now, after initial condition, we are here. Population will become fourfold, quadruples. Initially, population was 20. 20 now it is 4 times the population is equal to 20 e raised k when t is 2 days. T is 2 days. Initially, population was 20. 4 times means 80. 4 times 20 means 80. Now our population is 80. 20 times e raised to k. Shift this thing here. 80 divided by 20. We have e raised to k. It's our 4. It's our 4. To get this k not in exponent as a base, remove this e taking ln as a base. Ln e raised to k. It's equal to ln 4. Now power will become coefficient 2k times ln e is equal to ln 4. We are familiar. Ln is equal to what? 2k. 2k is equal to ln. 2k is equal to ln 4. 2k is equal to ln 4. What is the value of ln 4? Let's see. ln 4. That is 1.38. That is 1.38. Let me generate a space. That is quadruples 4 times. Here k is equal to ln 4 divided by 2. Value of ln 4 is 1.38629 divided by 2. Dividing by 2. K is 0.6931, whatever the case is. We have managed the value of k as well. Right here. C1 is 20. K is 0.693. Then jump to the final conclusion what we are asked to do. Okay. Now I have C is 20, if I am not wrong. My constant C1 is 20. E raised my K is 0.6931 times T. Okay. Now we are asked to find how much the population would be after 10 days. Population after 10 days. After 10 days. For T is equal to 10, population we are interested in. P is equal to 20 times e raised 0.6931 times 10. Multiply by 10. In that case, I have 6 point. It's good one. We are familiar how to multiply with 10, 10 or 100. 20 times. Just shift one digit here. It will become 6.931, whatever the case is. Now 93147. Just simplify this now. 20 e raised 6.93147 is 102 multiply by 20. It's 20. I have managed only this. It is 1023.998 multiplied by 20. We have P is equal to 479.96302, approximately the population of the bacteria after 10 days. It's our final answer. It's our final answer. It is hoped that now you are familiar to how to deal these questions. They are simple questions based on this fact, proportional, directly or indirectly. You have done many things in that. Don't get impression of these questions. It is simple one. You are familiar from direct ratio, indirect ratio, direct ratio, indirect ratio. The basic is same. Then you try some calculus. Then you try some calculus. Follow Newton law, and you are going to work wonder in that case. Inshallah, hoping you see for the next three questions very soon. It's all about save next.